Hello, everybody. Today, we would like to introduce Telecommunication Laboratory 1 Part 10. This part involves line coding. We will use two modules. There are the encoder and the decoder. Firstly, the sequence generator is used in experiment 1. This module is used to generate digital data. Okay, we connect the sinusoidal wave that have a frequency of 100 kHz to the CLK channel. Then we observe the analog output signal. Next, we connect the output Y to the oscilloscope. We press the run on stop button to observe the signals. Two signals are different because this module generates random signals. If we press the reset, the signal changes. When we zoom in on the signals, it looks like an analog signal. After that, we connect the 8.3 kHz sample clock to the CLK channel. Then we observe the output signal. We display another output signal on the oscilloscope. It is found that the signals are random. Stop the signals. If we press run and stop again, the signal change. It has two outputs. We can use whichever. We zoom in on the signal. It seems digital signal. Oh yeah! Experiment 2! We put the right code encoder in the immunogenes. We will use only one output signal. The output signal is connected to the data channel. Then we use the same sample clock. After that, we show the input signal and NRZY or non-return to zero level on the oscilloscope. The sine bit 1 will be converted to positive voltage, whereas the sine bit 0 is represented negative 1. We connect the B CLK channel to the CLK channel. Yeah, we will see the signal at this figure. It is observed that the output signal is slightly delayed. This is non-return to zero level. You can try to observe the another ones. Only dual binary is non-linear. Okay, experiment 3. Firstly, we put the right chord decoder in the immunitems. Next, we connect the NRZY of the encoder to the NRZY of the decoder. Then we connect the BCLK of the encoder to BCLK of the decoder. After that, we show the output signal on the oscilloscope. We will see the signals at figure. We can recover the input signal. It is slightly delayed because the clock sample is put back. If the signal disappears, we use press the reset. We change the type of right chord. We still can record the input signal. After that, we should dual binary right chord. We will see the signal like this. Next, we move on the experiment 4. We put the noise generator in the immunitems. We also put the adder module in the immunitems. Okay, we connect the dual binary to the input of the adder. Then we connect the output of the noise generator to the input of the adder. Next, we connect the output of the adder to the input of the right chord decoder. It is found that we can record the input signal again because the digital signal is robust to noise. We show the output of the adder on the oscilloscope. Then we set the gain of the adder as 1. We shoot the NRZY like code. We connect the output signal on the amplifier. We will see the signal like this. adjust the power of noise. The signal can be recovered. We increase the power of noise, the signal cannot be recovered. We connect the output of the decoder to the amplifier because the adder have the inverse property. Next, we will observe the spectrum of the signal. We connect the 8.3 kHz clock sample to the CLK channel. Then we connect the output X to the data channel. We connect the 8.3 kHz clock sample to the MCLK channel and connect the CLK to the BCLK. We show the output X on the oscilloscope. Then we also show the NRZY. We will obtain the signals like this. Next, we show the Manchester code on the oscilloscope. We will compare two signals. The blue wave is the NRZY and the yellow wave is the Manchester. It is seen that the Manchester have more frequency than the NRZY. After that, we observe the Manchester in the frequency domain. We will see the signal as follows. Switch to NRZY. Adjust the scale to observe the signal. Set the stop at 1 MHz. Then we change to Manchester. It is found that it is more content. Adjust the scale to easily observe the signal. This is the spectrum of the Manchester. This is the spectrum of the NRZY. It have the content less than the Manchester. Okay, finish!